Welcome in the arena. My name is Allyson Klein. We are coming up on the International Supercomputing event, which means TechArena is turning to high performance computing and everything that's going on in the scientific realm to see what's happening next in tech. Um, to do that, I have an exciting guest with me. I'm so excited to have her on the show. Trish Damkroger, Senior Vice President and General Manager for HPC and AI Business at HPE, is with us. Trish, it's such a delight to have you on the show.
Thank you. Super excited to be here.
So Trish, you and I have known each other for a long time, but you are new to TechArena. So we're just going to start with an introduction. You lead the team behind the world's three fastest exascale computers. That's amazing. Frontier, Aurora, and El Capitan. Can you walk us through your role at HPC and how you and your team work together to deliver AI and HPC solutions to the marketplace?
Sure. I have an amazing team. Seriously, it's over 2,000 folks across 140 countries. So
Wow.
we do have supercomputers all around the world, truly global. We go from product concept all the way through end of life of services. So I have a wonderful organization that, product development, engineering, deploying these big systems, which we have over 50 years of experience, and then servicing. So truly end to end. And we work, on both, just working hand in hand with our customers, which I think is what makes us very unique, because we're truly living on these customer sites. And we do both the traditional high performance computing and these large AI infrastructure build outs.
Now, supercomputing and international supercomputing are two of my most favorite times of the year because we get to tell amazing stories about how technology is being used for such great reasons. And ISC really sits at the intersection of science, sovereign research, and a wave of AI investment that I think is, to be honest with you, has surprised all of us about the speed and scale that it's moving. Where do you see HPC heading over the next 18 months, and what's shifting fastest from where you sit?
Yeah, so I mean, I would go back. I agree with you as far as the most exciting time of the year is these conferences. And the other thing that I think is so fascinating to me is how just at SC in November, how they couldn't fit all the vendors in the vendor space anymore. I mean, it
Yeah.
was like it was shrinking a couple years ago, and now it's just boomed because of AI. And I think that is the theme, right? When we go back to what is the definition of high performance computing, it is modeling and simulation, AI, and data analytics. 10 years ago it was modeling and simulation, and now we're definitely seeing true convergence of AI along with modeling and simulation. And as long as the talking about the vendor expansion, it's really about the need for supercomputers to power AI. It's the same infrastructure. It's that dense liquid cooling that's required across the board in order to power these. You know how much the TDP, or how much power the CPUs these days take along with the GPUs.
It's so funny because I think about myself as somebody that's lived in data center for over 2 decades, as, the geek in the room that's finally having their moment. And, for you being in HPC so long, the small community that has driven HPC really having their moment in terms of AI. And it's really all about AI infrastructure and what we can leverage from HPC. When you look at what you're engineering inside of HPE, and you've got the Cray systems now, the GX 5000 platform, how do you see that engaging to do things like traditional classical PC HPC, which you've been talking about, and then also deliver the trillion parameter AI training with the same system? What kind of engineering is it taking to deliver that type of capability?
Yeah, I think it's what we've been doing again for 50 years at Cray. It's continuing to look at how do you get the density and the power delivered to these systems so that they can do these world-class, time to solution development. So what we do is we still do have the densest solutions out there. The current portfolio is 100% liquid cooled, which is unique in the market. And that is how we can make them denser, so that you can fit more on your compute floor, which is important. And we're also make it vendor agnostic. So you can choose which hardware you want, software, open source, all the way through more proprietary, and even interconnect. When we go to the GX, we're really opening it up so that you can choose what you need for your workload.
It's
Truly, go ahead, Allyson.
it's so impressive. What you've been able to engineer is just really, it's astounding. But keep going.
Yeah, and you talk about being that geek. I mean, I do. I kind of geek out about this. I'm an electrical engineer background wise, I get super excited when I can see how we can truly power those big machines, and we just have that experience to deploy and scale, to exascale class systems, which I
Mhm.
think is also a very unique advantage. Now, I will tell you that the industry is definitely with NVIDIA and AMD pushing both rack scale design, and hopefully Intel, is also talking about it and getting into that market, that it really helps all of us because it increases the supply chain and our ability to have even more options.
Yeah, no, for sure. And that's such an interesting design point change. And hopefully we'll get back to that. I do want to talk to you about, I think, the word that is on my buzzword bingo card more than anything else in 2026, which is sovereign AI. And I know that this is going to be a theme at ISC. It was certainly a theme at OCP in Barcelona earlier. And we see it from a number of players. There's HLRS in Stuttgart, Kisti in Korea, Argonne in the US, who are all making moves in this space. What does this require from an infrastructure perspective, and why are national labs and governments turning to HPE to build it?
Well, I laugh because we've been doing sovereign forever, right? I mean,
Hmm.
this is kind of where the national labs and have sat for their history. And just thinking about the different needs, if you look at the EU regulations and the stuff about data security, governance and control, and the regulatory requirements that are coming down, this is just adding to the need for sovereign. And it's not just for nations any longer. It's truly any regulated industry, telco, pharmaceutical, all of that is requiring a sovereign approach. And you do this through a number of mechanisms. I mean, we do it somewhat you can do somewhat through networking, et cetera, but it's really about developing that software management and monitoring that allows you to know um, what's going on in your system, and allow that deeper visibility into your data and your data management and control.
Now, we all know that HPE tops the performance vector of the top 500, but something that we don't talk about as much, and we should, is how you sweep the green 500 too. You've got 10 of the top 20 most energy efficient systems on that list, and you have over 300 liquid cooling patents. So you must know something about driving heat mitigation from a energy efficient standpoint as well. When you think about, power climbing to hundreds of kilowatts per rack, how is your team rethinking the physics of rack scale and how you can, get so much compute and compute efficiency within those racks?
Yeah. So, I mean, our racks are up to 400 kilowatts, which again is the highest out there in the industry. And so
Hmm.
that allows us, again, to power a lot, but we got to do it efficiently because power is very expensive and also hard to get in some places. So liquid cooling is core there. And you do it through a lot of that liquid cooling expertise that we have been developing. Cray was liquid cooled. So way back then we were doing liquid cooling, and we've gone through so many iterations of liquid cooling, from immersion cooling to direct liquid cooling. And I think that's super important as we look forward. We're always, always looking at what is that next phase. We don't see immersion yet, and the going for two different phases as the answer yet. But these are the things that are going to start happening. You're seeing people actually putting liquid cooling into the chips. They're experimenting with that. I think we're going to get down to that level where we're doing, maybe even at that point, where it's a fully integrated package that you get with liquid cooling when you actually buy these high performance chips coming in.
I'm going to be
from
talking about that statement all day and what it means from a standpoint of the cooling market and the semiconductor market. That's so interesting. Um, but I wanted to get to you in terms of performance. And I know that you've got a lot of industry collaborations and you're doing a great job of offering a choice of systems to the market. But I did want to talk to you a little bit about NVIDIA in particular. You recently made some announcements with NVIDIA about bringing that Vera CPU blade and the Quantum X800 InfiniBand to the Cray line. But you also announced the Vera Rubin NVL72 system for the NeoCloud market. How do you ensure that you're delivering a full portfolio that makes sense to the market where you're addressing so many needs with such myriad solutions? How do you make sense of it?
It's a lot. I will tell you, my roadmap, used to be one page, and now it's many pages long.
Hmm.
Um, and you just have to obviously look at what your customer wants. And that's the end. We look at different customer segments and what we're selling to these different customer segments and prioritize by what our customers are asking for. So our more traditional, the GX, EX line that's currently in the GX coming, is very much more that traditional market where they do still want FP64. That's still important to them. They are going to do both modeling simulation and AI. So a convergence is needed. And they're going to look for different software packages that are important. They're also going to look at a network that needs to scale kind of to those large exascale type class systems. Where the NVL72 or those rack scale are really going into our, we're working with customers that are standing up these infrastructures quickly. They want them stood up in hours. They want them running in hours too, not days even. They have just that different requirement because it's a lot of our NeoClouds, our CSP customers, that just this insatiable demand to get the latest technology and get it up and running. So it's a different beast in some ways as far as the customer expectations. But
Hmm.
again, it all comes back to our fundamental understanding of, how to build large, dense infrastructure, liquid cooled, and how to deploy it quickly with some of the tricks that we've learned over the years, and then making sure it stays up. So
Yeah.
it's only good if it's reliable. So really putting in the monitoring capabilities and understanding what's going on in your system, so you have those flags if anything, needs attention.
I have a follow-up to that. For those who are following HPC and they may understand the convergence of HPC and AI, but don't really understand the nature of the various workloads that you're talking about. Can you just give a little bit more on the difference between floating point and vector-based computing and why this is such an inherent um, existential focus of these customers?
Well, I mean, it goes back to so traditional modeling and simulation has been always been floating point 64. So very, very, um, standard. All of their codes are written to take advantage of that.
Hmm.
And the investment you make in your code base, and if you look at some of these national labs, they have been working on this for years and years and years. And so to pivot is a huge investment, but it's also the fidelity of the calculation. So you get 64 bits of fidelity in that calculation. When you go to your AI systems, you may have 8 bits. And so you don't have the fidelity of the calculation. So the traditional modeling and simulation community, or that traditional HPC customer, is definitely using AI to steer their workloads. They're replacing some of their physics-based models that take a long time to converge with some data models that they've developed out of AI. So they're substituting in things to be faster, but right now they still need that fidelity of 64 bits.
Interesting. So, and when you talk about that years and years and years, that really leads into my next question because customers don't just buy a supercomputer from you. They're actually making like a multi-year or multi-decade commitment to you. So, how do you work alongside teams? And, you were on the other side of this earlier in your career. Like when you look at teams like Argonne, HLRS, and Oak Ridge, how do you work with them from architecture to code modernization to actually operational deployment to make sure that these solutions function in the ways that they have envisioned?
Yes. And I mean, it's such a different even buying behavior.
Hmm.
So for these customers, because a lot of times these customers are buying a system 2 to 3 years before the silicon is productized. And believe it or not, things change in 2 to 3 years, so you have to be working closely with the customer as all of these changes are happening. And again, maybe moving the customer from one code base to another, whether it's a vendor change or even modernizing, as you're talking about. We have centers of excellence that we have as part of this buying behavior where from day one, as soon as that contract is signed, we are meeting with them. We have people on site working with their algorithm developers, their application developers, to make sure that they are able to pivot as soon as the system is ready, working closely with whatever silicon provider they have chosen. We also, in fact, have these quarterly reviews. I mean, I know I'm going to be in Houston meeting with a core customer on Monday, doing exactly that. What has changed? What do we need to talk about? Where are we headed to make sure that we're aligned? Because when you are 2 years out, it does take a village to
Hmm.
get these systems up and running, especially when we're using brand new silicon.
That's incredible. Yeah, no, I can't even imagine the complexity of what you're trying to land from a standpoint of landing the plane of one of these supercomputers. And it's so impressive. I mean, you and your team have the privilege of having supercomputers that you're bringing to the market that have been actually recognized by the US government in a coin. I mean, how many people have that? That's so cool.
I know.
I
So
I've
cool.
written about
Yeah.
that on social. It's so awesome to see the recognition, not just of Cray and the foundational role that Cray has played, but of the importance of supercomputers to our society. I'm sure that our listeners have learned a ton every time I talk to you, and I've known you for years. Every time I talk to you, I learn something, Trish, and this today was no different. I know that the others who are listening or watching online are the same. Where can they go to find out more about what HPE is doing in the high performance computing space and how to engage with you and your team?
Okay. Well, if you're at ISC, come to the booth.
Hmm.
We're going to show some really fun stuff. And it's always a good time to talk about what is the latest technology that's coming down. And obviously, our web pages are the best to kind of keep up to date on where we're going, what's new, what's the latest. We're constantly trying to make sure that we are deal, giving you the latest. I think as far as the Cray coin, um, we are definitely wanting to give that to our core customers. We had a great instant, and I won't tell you which competitor, but even at one of the recent competitors, somebody stood up and started talking about their Cray system. And I was like, oh, I love this so much because Cray is just so symbolic of
Mhm.
HPC in the industry. So
Yeah.
I am sending that gentleman a Cray coin. So yes, mention Cray and let's talk about it. And you too can win a Cray coin.
That's so awesome. Well, thank you, Trish, for your time today. It's such a pleasure and have a wonderful time at ISC. I can't wait to see what HPE does there.
Thank you. Thank you so much.